Hi there, this is Nick from Antelope Audio. Well, in the previous video we heard the A4-1B and we saw it in action. Today we're going to dive into different features and functionalities of the compressor, and we're actually going to get quite technical and specific about it. So let's start with the basics. We've kept pretty much everything exactly the same as it is in the original compressor that inspired the A4-1B. On the left we've got the compress and bypass switch. Then next to it we've got the makeup gain with up to 30 dB of amplification. Next to it is the ratio knob that goes from 2:1 ratio to 10:1, and clockwise it increases the amount of gain reduction you're going to achieve. And to the right of the ratio knob, we've got the threshold. Now this one's an interesting one. In its full clockwise position, all the way to the right, it's at -40, and this is where the compressor will compress the most. Whereas if you place it all the way to the left to the off position, that bypasses all compression, but the signal still passes through the transformers and the tubes of the device, meaning that you can use it as a color box and get some of its harmonic distortion and tube flavor. All the way on the right, we've got the meter switch. This has three settings: input, gain reduction, and output. Now the input and the gain reduction is useful so you can actually meter the amount of signal that goes into the device. And as a general rule of thumb, you should aim it roughly at where the 0 VU setting is. And when you compress, it's always a good practice to try to match roughly what you see on the input and the output in terms of level. Meaning that when you bypass the compressor then and compare the compressed and uncompressed signal, you're not listening to a louder output after the compression or a quieter one, and you can more objectively judge what the unit's doing. The middle section, which is the gain reduction setting, shows you the amount of gain reduction that is achieved by the compressor. The amount of gain reduction depends largely on the program material, the instruments that you're compressing, and the settings of the attack and release and the timing switch. And this compressor is so cool that in some settings it can sound amazing even at over 10 dB of gain reduction. On the bottom row, we've got the attack and the release knobs and the timing switch. Now the timing switch is really important because here's where you're going to select the mode at which the compressor works. We've got fixed mode, we've got hybrid mode, and we've got custom mode. Now, the fixed mode is the easiest one to understand. In this mode, as the name suggests, both the attack and the release are fixed. The timing is always 1 millisecond for the attack and 50 milliseconds for the release. You won't change them by tweaking the knobs. They have no effect. However, this is very interesting mode because it's quite fast and snappy. And because of its speed, it generates more harmonic distortion and it's more audible than the hybrid and the custom modes, as I'll explain later. Now, that may sound like a bad thing, but it's actually really nice because this compressor in general is quite transparent. One of the magic that this unit is known for is that you can apply quite a lot of gain reduction without actually hearing the compression. In this mode, you're going to get a bit more character and it's going to be a bit more obvious than in the other modes. Because of its fast action, this mode is quite nice for instruments such as bass drum and snare drum. And if you also wanted to have a bit more of an aggressive action on a vocal, that can also be a nice mode to try. Next, let's have a look at the custom mode. In this mode, the attack and the release knobs allow you to fully control their timing. When we set the attack knob on the fastest, we're going to get actually 0.5 millisecond of attack time, which is very fast, even faster than that in the fixed mode. But when we set it all the way to the slowest, to the right, we're actually going to get to 300 milliseconds of attack time, and that's very, very slow. That's way slower than most other compressors available on the market. The release behaves in a similar way. All the way to the left in its fastest setting, it reaches 50 milliseconds of release time, which is identical to that of the fixed mode. But when we go all the way clockwise to the right, we're gonna get to up to about 10 seconds of release. Now, I hope you understand how slow this can be. With 300 milliseconds of attack time and 10 seconds of release, this is going to be a very, very slow compressor, making it suitable for something like orchestral music. Let's now have a look at the hybrid setting. Now, this one's a really interesting one because it combines both the fixed and the custom modes together. Now, some people may confuse it for what's commonly known as auto-release mode on compressors such as the classic British bus compressors or the old Rupert devices, but it's not quite like that. Now, in this setting, the attack is always going to be fast, just as it is in fixed mode of 1 millisecond. However, the release time will vary, and it will depend largely on the program material. So here we could have both very fast release, which is similar to the fixed mode, or we can have quite a long release that is similar to the custom mode. If the compressor applies gain reduction for a longer period of time, the release time will increase. And the way this works is that there's actually two envelope followers inside the compressor that are combined together to give you this mode. That's not quite the same as auto release in other compressors, where this is achieved by a dual capacitor network. Now, even though in this setting the attack is always fixed to the same behavior as in fixed mode, when we're in hybrid, the attack and the release knob settings will actually impact the release behavior of the compressor. If we set these to a fast setting, it is going to be the fixed mode that will dominate the compression. But if we actually set them to a slower setting, chances are that the custom mode release will take over. Well, maybe I can show you a couple of quick measurements which we did right before shooting this video. So here I've got just a test tone that is made out of basically a sine wave that was produced at different levels, one that is above the threshold and one that is below the threshold. This allows me to see the shape of the release. Now, while in fixed mode, you can see that I've got like a short transient and long transient, and for each I get the exact same release time. Here it is, the one for the quick transient and the one for the long transient. In hybrid mode, that's not the case. Have a look at the length here versus the length here. And we also get a very interesting release shape, which is very specific for this compressor, and in a way it's really instrumental to the sound of this mode. On the top left, we've got the makeup gain. Clockwise, to the highest setting, it achieves 30 dB of amplification. To the left, in its off position, acts as a mute switch. You can use that knob to compensate for any gain reduction that is achieved by the compressor, or simply mute the signal. So the last switch on the bottom is the sidechain link, and its off position, the compressor will act depending on the input signal, whereas if I place it to one of the bus settings, it will be linked to another compressor, allowing for stereo functionality where both compressors work in conjunction. The compressor that has the lower threshold will dictate the compression behavior. There's also a second bus option which allows you to link this device to another without having to patch at the back. So in the top right corner, we've got the VU meter. This is a classic VU meter with classic ballistics. It's usually set to +4 dBu, 1.23 volts, to equal the zero matching here. And you can change it from the software. A good point to start is to switch to the input metering here and make sure that the needle dances roughly around the zero. That means that you're operating at the standard operating level of the hardware. When you go to gain reduction, that is going to show you the amount of compression that you achieve. Now, with this kind of compressor, you can go pretty hard without noticing very obviously the compression. I would say that during tracking, something like 3-4 dB on a vocal, maybe 5 dB is a safe setting. And if you're gonna go for something like parallel compression, you can go as hard as 10, even 20 dB of gain reduction. Other than the on and off switch and the power LED, we also have the automation LED. Before we move to the innovative key feature of this compressor, the Antelope audio analog automation, let's have a sneak peek at the back of the unit. All the way on the right, we've got the input that's available both on an XLR and a TRS. Next to that, we've got the output, again available on XLR and a TRS jack lead. Then we've got the sidechain link buses, again on jack leads. And next to those, we've got the USB port, which is useful for automation and recall. Okay, let's move into the digital realm, where the A4-1B is one truly exceptional compressor. So the A4 stands for Antelope Audio Analog Automation. And what that means is that this analog compressor can be automated from any DAW, and we also have recall possibilities, even A/B preset comparison. The way we achieve that is by installing motorized potentiometers for the attack, release, gain, ratio and threshold controls. The blue LED automation light on the front panel indicates that the hardware is in sync with the software. Now let's give a few examples of how this can be useful. A, you can do an A/B comparison between different settings and check which one works better for you. B, imagine a song where the vocal in the verse is quite snappy and fast-paced and requires a slower attack and a faster release setting, maybe lower threshold. But in the chorus, you've got a longer sustained notes that are sung louder, where you might want to have a faster attack and a longer release. Well, you can do it by basically automating all these parameters in your DAW. So let's have a look at the software. As I already mentioned, the gain, the ratio, the threshold, the attack and the release are fully automatable, and that is because the compressor is equipped with motorized potentiometers. At the same time, the switches, which are for the meter, the sidechain link and the timing mode, can be changed only from the hardware, but when I change them on the hardware, you will see that that change is also reflected on the software control panel. So let's have a look at a few situations where this can be useful. Have you ever had a song where the chorus needs a different setting on the compressor than the verse? For example, the singer might be much louder in the chorus and you might need to adjust the threshold. Well, that'll be very easy. I can do it both on the software side here or on the hardware, and I can encode that into my DAW project, and that will change throughout the song. Another scenario will be when we want to choose a compression setting and we are split between two different possibilities. Well, just like if this were a software plugin, we've got an A/B comparison mode here. Have a look. I'll click A and I'm gonna have one completely different setting. I'm gonna click B and it's gonna change right away. What's worth mentioning is that even though it takes some time for the knobs to turn, the change in sound is instantaneous. Another case where this function is very useful is simply recalling your DAW project. You're no longer gonna have to look at your phone pictures or your paper drawings. You can just open the DAW project. Last, let's have a look at the sidechain filtering options that are available in the software only. The default mode is off, but we also have a DS mode. We have a low pass mode, band pass mode, and high pass mode. Each one of these has a steepness option of 2 filters that can be either second order 12 dB per octave or fourth order 24 dB per octave. The DS mode, as the name suggests, is for de-essing. In this mode, you will have a very narrow bandpass filter that will focus on the selected frequency from the right-hand knob. For instance, if I have some harsh sibilance around 8K, I can set that frequency to 8K. Or if I have some shh sounds, I can go maybe to like 3-4K. Now, this is going to be the content that will make the compressor act on, and therefore most of that will be reduced while retaining the rest of the signal uncompressed. Similarly, I can filter out the top end of my signal when I go to low pass mode, providing the compressor only with the lower part of the spectrum, which then will trigger it in action, and therefore more compression will be applied on the bass frequencies. And I could also set that to a high pass mode where the low end will be filtered out from the sidechain. And this is a very common mode when you want to soften a signal. I really like this mode sometimes for compressing my mix bus. You know, get out some of that bottom end, make the top end a little smoother, and allow the low end to pass through the compressor uncompressed, making the mix a bit bigger. And we also have the bandpass mode, which can also be very useful, and it allows you to focus mostly on the mid frequencies. It's worth noting that the frequency selection is fully variable from all the way down from 18 Hz to all the way up to 15 kHz. I could even double click on the frequency and type it manually here. Now, let's have a look at an example of where I might have recorded a bass guitar in a room where it had a room mode at 82 Hz, which is the note E, and that might be a bit overwhelming in the performance of the bassist. I can select the bandpass filter, go for the steep slope mode, and compress just that frequency, bringing it down in the entire performance while leaving the rest of the performance unaffected.